Guys. Good to see you on a Monday morning. Everything is going well here at the Able Homestead. Welcome to the office at my house. I would give you the tour, but I'm not going to. Everything's great. Liam was born Wednesday morning at 7:11 a.m. It was a little bit of a hair-raising ordeal. We went in Tuesday morning at 5:30. That's why I wasn't there Tuesday. To start the labor process, and then he didn't come for 26 hours after that. So it was a long couple of days. I've had fall break to recuperate. I will apologize. You'll see lightning in the background because I'm recording this Sunday night, just because I was lazy and decided to wait until the last minute to do this. So hopefully power will stay on and I can get this video done. No big deal. Pretty straightforward what we're going to talk about today. We talked last Friday about algebraic sequences. Remember, algebraic sequences is just a sequence of numbers where you're adding a common number to each number to get the next number. So the even numbers 2, 4, 6, 8, 10, 12, 14, 16 is an algebraic sequence where we're adding 2 to every number. 3, 6, 9, 12, 15, 18, so on. It's also an algebraic sequence where we're adding 3. The number that we're adding is known as the common difference. Now, I kind of showed you some of the terms that we were talking about when we were talking about a sub n and a sub 1. A sub 1 is the initial number or the first number in the sequence. A sub n is, let's say, the 100th term, and that would be a sub 100. Now, what I'm going to show you today is how we can write what we call rules, or that's a mathematical term for just writing a general equation for any algebraic sequence where we can actually work it out and find any term in the sequence. They may only give us 3 terms at the beginning of the sequence, and we can find the 2000th term given the rule. Okay? Now, there are 2 types of rules. There are explicit rules and recursive rules. Now, explicit rule is what we're going to utilize most often because it is it's the most useful. It's the one where we can write one rule and find the 2000th term and figure it out pretty easily. Recursive rule we don't use as much. The reason it's called recursive rule is we write it in terms of the term previous to it. So in order to find like the 1000th term in an algebraic sequence, we have to go all the way out and find the 999th term and then add the common difference to that term to find the 1000th term. So it's not quite as useful for numbers that are way far out there, but it is a little more straightforward when we're talking about the 5th term or the 6th term, so on and so forth, in an algebraic sequence. So reminder of some of the terms. If I write a sub 1, that means the initial number or the first number in the sequence. Okay? So whatever the first number is, whatever we start with, that is the initial number or the first number, and in algebra we call it a sub 1. Okay? We're going to use a here because we're talking about an algebraic sequence, and so obviously, the algebra starts with a. So that is how that works. So a sub 1 is the first number. A sub n is the nth number. So it's whatever number we're looking for. If it's the 34th term, it's the 3000th term, whatever, we would write a sub whatever that number is, and that's the number we're looking for. That's the number in the sequence that we're looking for. Okay, so you're going to see sequences written in a couple of different ways. The first way you're going to see it is just in a basic table where n will be 1, 2, 3, 4, 5, and then it will have the sequence numbers a sub n as 16, 24, whatever. And so you'll also just see numbers written in a sequence, and then you have to find it. It's all the same thing. Okay, the tables are just written in a more simplistic way so that you can know, okay, that's the first term, that's the second term, that's the third term. Those are useful for when we're using the recursive rules, which I'll show you here in this video. Okay, so that's what I want to talk about first. Whenever I'm looking for a number, a sub n, using a recursive rule, what I have to do is I take a sub n minus 1 and add the common difference. Okay, so basically all this is saying algebraically or mathematically is if I'm looking for the fifth term in a sequence, I go to this, that would be, let's say, a sub 5. So if I'm looking for the fifth number in a sequence, I would write a sub 5. Well, then I write, okay, what's 5 minus 1? Obviously, 5 minus 1 is 4, so the recursive rule for the fifth term in an algebraic sequence would be a sub 4 plus the common difference. So basically all that's saying is if I have an algebraic sequence that has 5 terms or 6 terms, I can go to the number before it, the number before I'm looking for it in the sequence, add the common difference, and that gives me what I'm looking for. Okay, the reason it's called recursive is re means going backwards and cursive means circular. So recursive means I'm circling back to the number before it, adding the common difference, and that gives me what I'm looking for. So this right here is the recursive rule for a generic algebraic sequence. Okay, so what does that look like in real life? What does that look like on the homework that you're going to do that I'm going to give you? So let's say I have the sequence -5, -1, 3, 7. Okay? So what would my a sub 1 be? Well, a sub 1 is the initial term, which is -5, which the nice thing about our recursive rule is we don't really care what our first term is. We only want to know what is the nth term or so on and so forth. So what if I'm asked, what's the fifth term in this sequence? And I should have put a ... because an algebraic sequence goes on forever and ever. Okay, so the two things that I need to know to find my recursive rule is I need to know a sub n minus 1 and the common difference. So if I'm looking for the fifth term, a sub 5, the only two pieces of information I need to discover is what is a sub n minus 1, which n minus 1 is 4. So I do a sub 4 plus my common difference. Well, what's my common difference? Well, what number is being added to -5 to get -1? Or is being added to -1 to get 3? Or added to 3 to get 7? Now remember, talked about this Friday, it's called the common difference because I can always find that by subtracting a later term by the term in front of it. So 7 minus 3 is 4. 3 minus a -1 is 4. -1 minus a -5 is also 4. So my common difference in this case is 4. Okay, so a sub 5, my fifth term in this algebraic sequence, or the next term in this sequence, because I have 4 terms, is going to be a sub 4, which is 7 plus 4. And 7 plus 4 is 11. So a sub 5 is 11, meaning the fifth term in this sequence is going to be 11. Okay, that's how you use the recursive rule. It's really pretty simple. All you got to do, find the number before it, add the common difference to that, and that gives you that term. Now, I said the explicit rule is far more useful. It's also a little more complicated. Okay, so what do I have to do for the explicit rule? So the explicit rule, is if I'm looking for a sub n, I start with a sub 1, which is my initial number, and then I add my common difference times a sub n minus 1. Okay, so basically what I do, same process here. Okay, so I'm going to write, we'll use the same sequence, okay? -5, -1, 3, and 7. Okay, so if I want to find the same fifth term, I already know my answer is 11 because I already did this with the recursive rule, so I should get the same answer. Okay, so I want to find the fifth term. Well, what do I have to do? I simply find my initial term, a sub 1, which is -5. So a sub 5 is -5 plus my common difference, which is 4, times a sub n minus 1. Now, what is a sub n minus 1? Well, again, we're looking for a sub 5. So a sub n minus 1 is, I'm sorry, it's not a sub n minus 1. It's simply n minus 1. I wrote it down wrong. It's just n minus 1. So I'm looking for the fifth term. Oops, where am I? I'm looking for my fifth term. So all I have to do is multiply 4, my common difference, times 5 minus 1 is 4. So my fifth term here is going to be -5 plus 16. Okay, and what is -5 plus 16? Again, a sub 5 equals 11. Now, again, this is where the explicit rule is way better than a recursive rule. Because with the recursive rule, a sub 5 was pretty easy to determine because I already knew what a sub 4 was. I knew what the fourth term was, and so I could just add 4 to the fourth term to get the fifth term. Where the explicit rule is a lot cooler and far more useful is I can find a sub 152. I can find the 152nd term in this algebraic sequence, which I'm not really sure why you would want to find the 152nd term in a sequence, but it's cool that you can. Because all I do is I do the same process. I start with my initial value, -5 is the first number in my sequence, and then I add the common difference, which is 4, because that's the number that I was adding, and then I multiply that times 152 minus 1, which is 151. Okay? So that means the 152nd term is -5 plus 604, which the 152nd term in this algebraic sequence that started at -5 and we're adding 4 to every single value ends up being 599. So that's how we use explicit and recursive rules for algebraic sequences. Now on your homework, you're just going to have like 6 different sequences. And all you have to do, it asks you to write both a recursive rule and an explicit rule for each of the sequences. So all you're going to do is you're going to stop at this step right here, except you're going to replace a sub 1 with the first number. And then you're going to replace d with the common difference, and then you can write n minus 1, or if it asks you for a specific value, if it asks you for the 7th term, then you do 7 minus 1, which is 6, to find that value. If it just asks you for the rule, then you would write a sub n equals -5 plus 4 times n minus 1. With the recursive rule, it would just be a sub n equals a sub n minus 1 plus whatever the common difference is. If it just asks you for the rule, you're going to be a sub n and a sub n minus 1. If it asks you what is the 15th term in this sequence, that's where you're going to substitute in and find those values. I think most of your homework is just finding the rules though. So here's the deal. I have put the worksheet on Oasis, so you can do that on there. You could just type in your answers. With the a sub n, you can use the math little tools on the subscript, or you can just write a n equals an a n minus 1. I'll know what you're talking about in the submission box on Oasis. So don't worry about that. Just as long as there's a moth in here. Just as long as I can understand what you're getting at and that you have a general understanding. If you have questions, I will probably be doing a video each evening for my Algebra 1 classes. If you have questions, I will try. If it's a question that's just for you, then I will answer that question via email. But if I keep getting the same questions from several students, then I will address it in tomorrow night's video. So that's really all there is for the algebraic sequences and the rules for those. Again, if you have any questions, please email me. Look forward to seeing you guys next week. Thanks, guys.